So unit 4 we're doing 6.6 logarithmic and exponential equations. So again, we're trying to solve for x, but now we're in the form of either a logarithmic or an exponential equation. So we're trying to find what x is to make each side equivalent. So one of the properties we pick up on here is, since we have the log of 6 on both sides, one of the rules is if we have let's see if I can get my green marker to come into play. So if I have the log of m base a is equal to the log of m base a, since we have the same log on each side, what has to be true then is, then let me make this an n, not the same exact thing. The log of n base a. What I can conclude then is, for the left side equal the right side, m must equal n. So if I look at our problem, we have this 1/2 the log of x base 6. So the log of x base 6, it's equal to 3 the log of 5 base 6. So we also got to use our properties of logarithms here. Notice this 1/2 can come back in as an exponent. So this becomes then the log of x to the 1/2 base 6 is equal to, and this 3 can come back in as an exponent, the log of 5 to the 3rd base 6. So since these are both base 6 logs, what has to hold true then is the x to the 1/2 has to be equivalent to this 5 cubed. So what we're trying to do is figure out what number can I raise to the 1/2 power that's the same thing as 5 cubed. So x to the 1/2 has to equal this 5 cubed. Now remember, 1/2 is the same thing as the square root symbol. So the square root of some number has to be the same thing as 5 cubed. What is 5 to the 3rd power? That's going to be 125. So the question is, how do we get rid of the square root symbol? Well, the inverse of squaring is actually the squaring. So the inverse of square root is squaring. So if I square this side, I have to square this side to keep them equivalent. So since these are inverse operations, they will cancel out and just leave you the x. And then all I got to do is figure out is what is 125 squared. So it's going to be 15,625. So x would have to be 15,625. So that's my solution set. So there is a solution. So if I wanted to test it, I could put 15,625 into this problem. So I have alpha f1 1/2, and then math log base. We got a 6 there. Now instead of putting an x there, I'm going to put this 15,625. Hit enter. That gives me that value. Then if we do 3, and then again do that math log base guy, and put a 6 there and a 5 there, I should get the same answer. And we do. So they are equivalent. So that does check out that 15,625 would be the solution to this problem.